Hello everybody, it's Alexander Sopcich again. Welcome back to the Programming is Easy series. Now first of all, I'm going to assume that you are capable of installing this software yourself. If you're not, I'm going to be able to just give you a link to my other videos, one of which is actually just how to install these two pieces of software. Really what you do is you go to this link, which I will give in the description, and then this one. These are Java and Eclipse. These are what we're going to program in this video. All you do is download the installer for this and download whatever the latest development kit installer is. Not demos and samples, development kit. Right now it's the 74th. They move through them pretty quickly and get them for the right PC. You should be able to figure out, I think, whether you're 64-bit or 86-bit. But without further ado, let us begin. So, if you haven't installed it, you should do that right now. Pause it, do it, and then come back while, Eclipse loads for you. So, I'm assuming that you've already installed it now, that you've paused the video, installed the software, so now we can start. First of all, it's going to ask you to make a workspace, which it'll set a default, and you can just press OK and it'll be fine. That's just where all of your stuff is going to happen. It's sort of an area for you to make your projects and such. Then it'll take an eternal time to load, which, come on, I believe in you, computer. There you go. So, I already have some stuff open here. This was where I was sort of like developing what I was going to show you guys. But now what we're going to do is we're going to make our own. And what we're going to be doing here is actually Connect 4. Yep, we're making a simple game, but we're going to be doing it completely from scratch. So let's begin. File, new Java project, call it Connect 4. Oh, okay, fine. There we go. Finish. That'll create the project. In here, we will. Oof, that's weird. Seems I already had something like that. Let's start that again. New Java project. Connect 4. There we go. Finish. It's going to make a new one for us. It's fresh. Then here, SRC is where all our code is going to go. So we're going to make a package in there. A package is just a way for us to say, this is all of the code that's relevant to this. We're going to say just Connect 4. And generally these have your website name in mind. So they'd be like com.google. whatever or such thing. So then inside you make a class, and there's where the actual code goes. So we're going to name it. We're going to make two actually. We're going to make one called reference, where we're going to be learning how stuff works. We're going to check this checkbox, which basically sets up the place where we're going to write our code, where we're going to be able to say run and the code's going to run. So we're going to have this reference.java. We're going to be able to sort of like learn the basics. For example, how to write code. So let's do that for now, like right now actually. So first of all, that thing I got rid of really isn't important. It's just sort of an area there that says this is where your code goes. So this package, that's saying this is where my thing is. Class is where all code needs to go, whether it's variables like data and such, or functions like this one. And then functions are where things need to actually happen. So you can't make stuff happen outside of a function other than creating a variable. So, without further ado, let's make something. The simplest thing to do is hello world. Remember, everything has to happen in sort of a line of code is a single thing. So we're going to do our single thing, which is going to be a print out statement. So system.out.print line. It doesn't really print out line. It doesn't really matter what that does or how it does it. What matters is that's the sequence of stuff that basically tells us we're going to print some stuff to the console. We're going to say hello world. Okay? If we press either this play button up here or Control F11, it will run the code. And there it is. We've printed hello world to the screen. And obviously we can print just about anything else. We can print also other variables that are not really things that are meant to be printed, but it will convert them. So say we want to print the number 52. That's not really a printable thing on its own, but it converts it for itself. So we can say, for example, this, or we want to say this number is, and what we do is we make the printable thing and we say a plus to smack them together, basically. And it'll say that. So yeah, you probably want to have like a comment or colon there. That's how that works. Doesn't really matter why that works or how like that works internally. It just means that you put a thing, a plus sign. If it's just a sentence or a word, then you need to put it in quotation marks. If it's a number, then or some other value, then you just put it there. So next thing, we want to actually know how to deal with numbers, do math with them. So the way we do that is with variables. Variables are storage containers for data. So we say, for example, one is the integer. So the way we declare one is say the type. So we're going to make an int, call it like myInt, or how about just x. And then we set it equal to something, because a container really isn't useful unless it's holding something in it. So we're going to say 51, not 52. There we go. And then we'll be able to print that out too. So one useful thing about Eclipse is we can say, we can autocomplete stuff for us. So we can say sysout, control space at the same time will autocomplete the code for us, because it's a long thing, sucks to type. So we can say, for example, x equals, really here, so this doesn't mean anything really, it's just us. We can say, x equals like this, and it's the same thing really. And then we say plus whatever the x was, and then it'll say x is 51. And there we go. If you want to do math, so we can make another one called y, and really, you don't have to set them equal to something. The container is perfectly legal without something in it. You just can't use it. And you can say like y equals to 32 later. And then say we want to do some math. So we're going to say z, or int z, equals to x plus y. So we're going to print out, let's say z, or just x plus y, and we're going to print out z. So now what's happening is it's saying 51 plus 32, and then this thing is 51 plus 32, and we're stuffing that into z, whatever 51 plus 32 equals. And, well, it's 83. There we go. So we can do math, we can do subtraction, there we go. We can do multiplication, we can do division, although since they're integers, they're probably going to say, 1. Even though it's not really 1, it has decimal points, but it basically throws away anything that involves a remainder if it's integers. So we can do math with integers. Let's keep going. So there's another type of thing that's important. It is called the Boolean. So we create them like that. And Booleans can either be true, so we say like, my bool, or B1. So they can either be true, or they can be false. And what that means is this signifies all of those logic gates I was talking about. We can do things with those logic gates, those on and off values. This sort of allows us to think about them in a way that makes sense for us, true and false, 1 and 0. And if we want to print those out, then we can do that. So we say B1, it'll print out true. So how in the heck are these useful? Well, what we can do is use these things called if statements. So for an if statement, what you do is you say if, and in parentheses, you put something that ends up being a Boolean. It doesn't have to explicitly be a Boolean. You don't have to say B1. Here's a thing that evaluates to a Boolean in the end. But we're just going to say B1, and then we're going to put those open curly brace and close curly braces, and all of the code that happens if B1 evaluates to true happens here. So we say sysout, and we say, B1 is true. Now, what if we want to do some stuff when B1 isn't true? Well, we say else. And, we say B1 isn't true. So if we set B1 to false, then bam. Now, another thing we can do is do else if. So what if we want to check if B1 and then if B2 is also true? So else if, and that also needs a parenthesis thing. That's why it's all red there. So we're going to say else if B2, and then we say sysout B2 is true. And again, I'm expecting that you guys are going to be pausing this every once in a while to look at the code, because I'm going to be hurrying through this. We're going to be going through a lot of things. This is like 2 quarters worth of university lectures in half an hour-ish. So there we go. B2 is true. There we go. So it's saying that. But what if they're both set to true? Will it run both pieces of code? Well, no, actually, it just runs the first piece of code it gets to. So it gets to here, it's like, okay, is B1 true or not? Yeah, okay, screw the rest of this stuff. If it's not, then it goes to here. So really, this else if isn't B1 is true. It's B1 is true and everything before isn't. So, again, how are these things useful? How do we check things? Well, let's say there's also a bunch of things we can do called Boolean operations. So these are the logic gates that I was talking about. So we can say, for example, Boolean correct username, right? So say someone is logging in and we have these Booleans that define whether or not the person got the correct password and username, right? So let's say they did log in correctly. How do we check if, they're both true, if the person is logging in correctly? Well, what we can do is we can print out, and we're just going to put these straight into the print thing, okay? So what we can do is we can do the AND operation of them. So we can say correct username, or correct password, and with 2 ampersands, correct user. So what that'll do is it will print out a true only if both of these are true. So this turns out to be a Boolean also. The combination of them turns out to be a Boolean. And it turns out to be true unless either one of them is false or if both of them are false. So notice that it'll be false there too. So let's say we want to make the login system print some stuff out. Let's say we want to say if correct username and correct password. Then we want to say we want to print out that, logging in because, they got it right. And there we go. Because he didn't get the correct password, we're not logging in. If we got the correct password, then we're logging in. There we go. And then we can say else if, correct username. We can say that, okay, well, if both of them aren't correct, it means one of them must be incorrect at the very least, which means that the one that's not correct username, if correct username is true, that means the other one is false. So that means your password is wrong. That's a bit of mental gymnastics kind of, in the good kind of way, but it does make sense logically. So we're going to say, the password is wrong. And of course, we say, let's copy this over because it's easier to just copy it. If correct password, then it must mean that the username is what is incorrect. And finally, if neither of them is true, well, that means that we've got something that's, everything's incorrect. Put a little frowny face. So logging in, if we make this false, it'll say the password's incorrect, which it, isn't. And, say false here. Then bam, username incorrect. And finally, if they're both false, if you got both things wrong, then everything is wrong, frowny face. So, how is that useful? Again, we got to keep thinking, why is this helping us? Well, we can check if math is correct. So one thing we can do is say int x equals to 5, int y, oh, we're not going to do x, let's do var1 this time and var2 equals to 7. What we can do is we can say if var1 is greater than var2. Now we're going to print out that, just var2 greater than var1, or less than var1. Now it lets us compare numbers, which really means quite a lot. It means we can make decisions based on whether things are correct. Say, in our Connect 4 game, if someone tries to put it in, say, like, I want to put it in a -1th slot. Well, that doesn't exist, so we can check, is this less than 0? Then we don't want to to do that. So, right now, var1 is actually greater than it, or actually less than. So let's say we want to make it greater than. 8 is greater than 7. If we run this, it's going to say var2 is actually less than var1. 7 is less than 8. We can also check if they're equal to each other with a 2 equal sign. Remember, don't do 1 equal sign because we're already using that to set variables to each other. So if we make these equal, we say var2, then bam, these two are actually equal to each other. So let's actually start one last thing, and then we're going to start on the actual game. Okay? So let's begin with arrays. So first of all, all of this math and stuff we could do ourselves. Why do we need computers? Well, computers can do a lot of stuff really fast all at once. And the way we do multiple things of the same type is through an array. So we say an int, but we put these brackets, which mean there's a lot of ints. They're all ints, but there's a lot of them. We say, so like int array or something. And we set it equal to something, which could be, setting it equal to specific numbers. So we say open curly brace 1, 2, 3, or 1, 2, and 4. So they keep looking for number 3, har har. And we can start accessing that. So sysout, let's do a sysout of int array. Okay? What's weird? Why are we getting all this jumbled garbage? Well, actually, this isn't really those numbers. This doesn't hold all the data. This just holds the location of the first piece of data. Really, in the computer, it works kind of like a train of data. This says, okay, this is the first one, and it's that long. And then it knows how far to go to get each other, value. So, what we do, instead, to get the values, is we say, let's get the first value with an open square bracket and close square bracket and a number. But that's weird. It's giving us the second one. Well, remember how we start counting at 0 generally? We normally count at 1. But really, 0 is the first number that exists. And in computers, we prefer the number 0 to be the first number. So there we go. The 0th number, element in this array, is 1. 1 will be 2. And, the third one will be, the third one, which will be 2 in the list, will equal to 4. So there you go. There's your arrays, how to use them. So let's say we want to actually do things with this array. How do we do them? Well, what we want to do is make a loop. So loops are weird. There's 2 of them, and they're not really difficult to use. The simplest one is the while loop, which goes similar to the if statement. While this Boolean thing, for example, we're going to make an integer, say, int iterator equals to 0. And you're going to get why we're using this soon enough. And while, say, iterator is less than a certain number. Open and close curly brackets. Now what we're going to say is iterator plus equals to 1. And that's a kind of special way to say we're adding a certain number to it. In fact, if we want to do 1, we can say just plus plus. That'll add 1 to iterator. Now iterator will be 1 if it started as 0. And let's also print out iterator. So what this while loop is going to do is it's going to go through, it's going to check if the iterator is less than 10. If it is, then it's going to keep doing this thing. So 0 is less than 10. We'll print out the iterator, add 1. And we'll keep going down. And you notice that we ran this loop exactly 10 times, and we went through each value of iterator. How is that useful for us, to do math with? What it does is it lets us iterate through an array. So in fact, this is such a common way to loop that while loops aren't even what we normally use. We actually generally use a for loop. So a for loop looks like that. You start out with your integer that you're iterating with. So there it is. That iterator is int I equals 0. We set it to whatever initial number. We could set it to 5 if we want. Then whatever number we're waiting to be greater than, whichever number we're stopping at, which is that. And finally, how quickly we go up. So we can say plus equals 2 or something. We can make it iterate twice over. We don't need it really, but we can. So this does all of that for us. So if we do a printout of I, then it'll do the same thing here. So let's get rid of this. We don't really need this anymore because while loops are useful, but not to us at the moment. So this will do the exact same thing. So see, it's actually even checking that the length of the array here, which is just this dot length, is 3. So it's saying that while it's less than 3, it's going to run. So in fact, what we can do here is we can even just get the data from the int array. So we can say int array of I, which means that it'll first get int array 0, then 1, then 2, and it was like, oh, we're out. So there we go. There we're getting all of the elements in the array. So what we can do with that is say we were going to make our game. All right, and we wanted to say this is a column, it can hold 8 things. Well, we're going to make an int array called column. And it's going to be, we want to all, just have all empty spaces there, just zeros basically. So we're going to say, instead of like making a, curly braces and then 8 zeros, what we're going to do is we're going to say new int of 8. And that'll say just put zeros in all 8 of them. And by the way, it's 8 things long. So what we can do there is we can do the same thing here, iterate through it. And let's say instead of print lining, we'll print so it doesn't, put things all in line downwards. We'll put in line forward, and we'll say instead of int array, we'll say column of I. And let's add some spaces between the numbers for the sake of understanding what's going on. And of course, we want to say that that's the thing that we're actually checking. So there we go. So we've got, 8 zeros. Now obviously they're in a row. In the end, we're going to print them as a column. So let's actually do things with this in our game. So first of all, one last thing. Our game, we've got a grid, not a single line. We've got 2 dimensions, not one. If you think of this as a line, a single dimensional thing where you can place things anywhere here, then really what you want is, well, a 2-dimensional array. Can we do that? Well, yes, we can actually. We can say int like that. Now, what does that mean? What does that mean if we say that that's the, grid equals new int of, like, say 3 by 3? Well, what we're saying is we're making an array of the type int array. So what we're doing is we're making an array of arrays. And that's evident if we make a for loop where it's iterating over the grid. And we can actually set a value called, grid line. And we're going to say like int array grid line equals to grid of I. So that's not giving us a syntax error. And if we want to, we can make another for loop here where we go through each line in the grid, for each thing in the grid line. So we can say for, and we can say use the word j instead, the letter j instead this time. We can say, instead of grid line, gridline.length, we can say, sysout print, in, whatever value is in there. So grid line of j. And let's not print line, actually. Let's print it and then put a space. And then down here, we'll do a print line. So every time we finish a grid line, like finish a whole line of numbers, what we'll do is we'll end up having an extra, we'll make just a print that's just a line. So what it does is it ends up going to the next line for the next thing. So there we go. We've still got a bunch of this crap here, so might want to get rid of this little column stuff here, but yeah. So there we go. There's our grid of numbers. And if we want to access a thing, you betcha, if we want to just get a straight one from it, we can say grid of, let's say we want to get the middle one, so we want to say 1 and 1. So that's how we access it. And we say equals to say, 55, 4. There you go. If we print out all of those, it'll say, bam, there's 54 in there. Now, we should be able to start our game now that we know all of these things. So I would suggest keeping this thing open that we've typed out, probably not deleting all the things that we wrote, like I did, and creating a new class, and we're going to call that class actually Connect4. We're going to make another main thing in it, and we're going to start actually writing stuff. So now we've got 2 files, one that we're sort of practicing in, one that's actually going to be the code. We're going to leave the one that we're practicing in here, and we're going to put the actual code here. So, first of all, get rid of that again. We got our code here. So first of all, let's make our grid of our board. So we're going to make a board array We're going to make an array that holds everything about our board, all of the pieces. Every location is going to be an integer because, that's what's easiest for us. And we're going to say, board equals to, and in connect for, it's a 7 by 8 board. And let's arbitrarily, remember this is us doing this now, define a 0 as an empty space, a 1 as a red piece, and a 2 as a yellow piece. Remember, this is something that we're thinking about it ourselves. Really, the computer doesn't see red, yellow. It sees 0, 1, and 2. This is called enumeration. It is actually built into Java. However, it means we'd have to learn how to use the Java version of it. And really, this is simple enough that we don't need to. So if we're arbitrarily defining these things like that, then first of all, let's be able to print this board, right? So we'll do the same thing we did here, except with the board. So we'll do a for loop, board.length, and really, we want to print out, every row, but what we've got is essentially an array of columns. So we've got to get the first thing out of every column, the first value, and then the second value out of every column. In fact, let's just demonstrate that. Let's say, we're just going to make a for loop where it's just 2 for loops, where this is taking the length of whatever, we're on right now. So this is the length of the whole thing. And this second for loop is about the length of the thing that's inside of, the actual column that we've made. And then we say, we're going to print out this this board of ij, because that's the thing that we're on. Those are the numbers. Remember these iterators? So it goes through, from 0 to, well, it's going to go from 0 to 7, and then it's going to go, so it's going to go from 0 to 8, and then 0 to 8, and then 0 to 8 again, 7 times. Okay? So we're printing that out, and we probably want to just print, and then again add a little space. And then here, again, we want to print out a line so that it's not putting them all in one line across the bottom. And let's print that. So it looks like, first of all, it's printing extra things, which is strange. Which is actually, oh, there we go. I don't know why that said error in it. There we go, system.out. So now we've got that. So weirdly enough, though, this is 8 across and 7 down. Why is that? Well, really, because we're printing a column like this. So this is one column. This is the next column. This is the next column. So really, our thing is kind of flipped. We've got to flip it around. So how do we do that? Well, it's kind of more mental gymnastics. What we've got to do is we've got to say that the length of a column, we want to print each row. So we want to print each row. There's going to be 8 of them. So we want to print 8 times, and that's going to be the length of the column. So we want to get a column, and we got to get the length from it, and then we got to say print out, every row, and we got to get the length of a row, which is just going to be the length of the whole array. And finally, we've got to switch the j and the I here so that, well, we're accessing the correct things now. Because I really is going to be accessing the columns, and j is going to be accessing the rows. It's kind of a weird trick, but it's something we have to do. So see here, now it's oriented the correct way. So we're able to print it, but really this is a crappy way of printing it. Why don't we print it in such a way that makes sense to us? So this is where we start using those if statements for our game. Instead of printing out the numbers, we can say if board of j of I equals to 0, or 1, let's say 1, we're going to have it print out red. So sysout, or, come on. Yeah, we're going to have it print out a R space. And then if it's yellow, we're going to do the same thing, except we're going to say if it's 2, we're going to say yellow, or Y. And then else, we're going to say sysout, we're going to say print out a dot and a space. And then we're going to get rid of this final thingy. So what's going to happen is, depending on which thing it is, it's going to print out that type of thing to show us what it is. All we've got here, and by the way, these really should be prints, not print lines. We get kind of carried away going quickly, but there it is. We've got our grid now, and if we artificially set one of the pieces, say we want to say board of 3 and 4, again arbitrarily, equals to 2. So we're going to make it a yellow piece. Then bam, there's our yellow piece. Starting to look like a game already, right? However, you know, there's no gravity here. All we're really doing here is making sort of our engine, our text-based engine, so to speak, for our board. We're dealing with how to display things, how to print them out, how to make it so that we can, you know, change the game, you know, the system. So let's keep going. So we've got this. Now, it would suck if every time we printed, we have to copy and paste this massive, well, really piece of crap. So what we're going to introduce is making our own custom functions. So we've got this main function. This is a function. But really, we should be using our own functions too. So we're going to go back into our reference or practice, and we're going to make our own functions. So functions, first of all, can't be defined inside of other functions. They have to be made inside of a class. So we're going to get to the end of this. So if we look at this thing, the end of it is here. So we're going to make our function here. And it doesn't really matter what this public, static, void stuff means. All it really means is that basically this function can only be run, you know, in this class, and, well, anyone can run it. So we're going to name it something like my function. We're going to look at how functions work. So first of all, again, like if statements, everything that has code inside of it has curly braces. This function on its own will print stuff out if we say, you know, we just run this code, we tell it like, hey, print out my function. What will happen is if we call this function, the way we call it, by the way, is we say just my function and then this thing, it will run. So it'll say, I'm looking for this thing. Hey, there it is. Hey, let's run this code, and then once we're finished, get back here. And there it is. It's saying my function. What you can also do is you can send it information by passing arguments. So if we say in here, int input, then in here we actually have to give it something. So if we give it like a 57 or 56, then what we're doing is we're saying my function of 56. So we're putting 56 into this int input, and really what ends up happening is we can actually access that, you know, int input now and say, you know, input. And what that's going to do is it's going to say my function colon 56. Lastly, void is a weird thing. Void means that this function doesn't give anything back. And that's oftentimes good enough. However, a lot of times your functions have to give information back. And the way you define what they give back is literally the same way as you do regular stuff. So how do you actually give it back? Now that we've defined it, that it's giving back an integer, we can also have it give back an array of stuff. We can give it back, essentially have it return anything. We say return, and this is the end of the code right here. This means that this is where the code ends. If you have stuff here after the return, then it's not going to happen. So we're going to say return say input plus 2. So what's going to happen is it's going to say my function of 56 is going to run this code, and it's going to be like, okay, let me replace this with a 52 or 56 plus 2, which will be 58. And now this will act as an integer essentially. So you can say actually int return thing equals to my function. And we can actually print out the return thing. It should say 58. See, there we go. So one thing we could do, so for example, for printing, we can say public static void print board. It's going to need an argument of, you guessed it, an int array of board. Call it board because that's what it is. And we're going to put all of our code that does that actually prints the stuff out, in there. And there we go. And we can actually get rid of it here now. Where is it? There we go. And we can just say print board of board. So what it's going to do is it's going to pass the board in here, and then it's going to do all the same code with the same data, except it'll take us less here. So if we want to print it again, if we want to say print board, right, and then we want to change a piece, for example, right, so we want to say set that, we can print the board again without extra code, really. So there, we did something, and then we have the piece. Now, obviously, this doesn't look too pretty, and there's not really anything cool going on there. Like, it doesn't look like an actual game unless you've got pieces on it. So really what you should have is a bunch of graphics, but you can do that yourself. I believe in you. Later on, after this is over, let's look at finally, actually, well, that's really it, isn't it? All that we really care about now is user input. So, this is fantastic. We can write the code and it'll run the same way, but we wanted to make this a game. This has to be a thing that people interact with. So that's why we're going to use this thing called a scanner. And scanner, actually, you need to import some stuff. And here, if you just press Control-Shift-O after you've written the thing, it'll import for you, but that's what you import. Basically means there's a lot of code that goes into getting stuff that you've typed into the console. And we don't really care about making that stuff. So we just want to use it. So we say scanner scan equals to, and this will look like a new type of variable, but really it's just an object, and you can make anything, you can make a variable that's named any kind of type as long as it's an object. Doesn't matter though. Just we're making a scanner called scan that takes system.in as the input for it. And we got to say new scanner just like with the arrays. So scan now has a bunch of stuff that it can do. It is an object, meaning it has both variables inside of it, like which thing it's getting input from, and also it has functions. So we can say input string, and by the way, we haven't done this, but all those things like this, these are called string variables. They are created like this. Same way, you either give it that, or you give it some other thing. So scanner, scan dot next line gives, the next line of input as a string. So then we can print out in string. So sysout in string, and we can say, we can run this code. We can say, I'm writing this, and then it will say like, and then, there we go. So that's how we get things from people. So we can say, actually, is we can also split things up into different sections. So we can say, so now we got this in string, right? It's multiple words. We can say, we can make a string array, right? We've already made integer arrays. Now we can make a string array called words. That's just a name that we give it. We can call it poop for all we care. We can say in string dot split, and that's just another function that in string has. And then we tell it we want to split it based on every space that we see. And we're going to give it a string that's the space. We can give it a string of actual words too, but we're going to give it a space. So if I type in a bunch of words, and actually we're going to stop this because we haven't finished writing the code. And we also want to print out obviously the whole thing. So we say for, and then we just say, sysout of word. We want to get whichever thing it is, this one, words of I. So we write this, we say, this is multiple words. And what it'll say is, well, there's one string, there's another string, there's another string, and it all puts it all in one array. So there we go. And one last thing we can do with them is turn them into integers. So we can say int input int equals to, let's say we want to say, just how about input, in string, and we'll just give it a single number so we're not screwing with it. And actually, the way it really works, we say integer dot parse, because really, the string denominations of the way something looks like an integer really has to be, done by code. Like someone has to look at it basically and say that's what that kind of number looks like. So some piece of code has to do that, and it's called a parser. And then we're giving it the string, which is going to be called, in string. And we can print out that input. In fact, we can do input int. This is an integer already, this integer.parseInt. So we're going to say +2. Then we're going to say sysout of input int. And then, bam. So we're going to say 24 as our input, and bam, it gives us, first of all, 24 is the thing that we got in. 24 is the only word there, and then 26 is 24 plus 2. So now we can actually do input. So say instead of this, we first of all print out the board, right? Then we print out an extra space. Then we say we want to import a scanner. We're going to make a scanner first. We want to say scanner scan, same thing here, equals new scanner. Press Control Shift and O again. Okay, and then we want to say, moves equals to scan dot next line. And then since that's already a string, we can say dot split. So we can sort of, put a bunch of stuff after each other, sort of chain it. Then finally we can say, because we're intending to do what? We're intending our input to be a number, then another number, then finally a third number. So we're going to say, also this is going to have to be a string array moves. That's why it was red. If you ever see red, you should watch the rest of the video because that means I screwed it up somewhere and I'll figure it out later. Then we're going to say, int x, and we're going to say, we're doing the row first, then the column first, so int x equals to the x value of the thing equals to moves of 0. And we're going to do the same thing with integer dot parse. Right. Oh, no, there we go. Yeah, Eclipse does crash quite often, but generally not this often. So there we go. We say, the second thing that we're sending as an input is going to be the y value. And finally, int player equals to integer.parseInt of moves 2. And you may notice that, well, what if we put the wrong input? Well, it sucks. In fact, that might be one thing that after you're done watching this, you might want to do yourself to improve this program, to make it so that you can put in correct inputs and it will just give you an error message instead of crashing. So we got all that. We can say, now, we can say board of x and y equals to player. And there we go. So it's got our input, and we're going to say 3, 4, and 1. And bam, at 3 over, see that? 4 down, and red. So there we go, there's our input. And finally, remember that while loop? Because we want people to be able to play, make moves over and over and over again until basically forever. We want to put all of this crap into a while loop. But not all of it, just the stuff that needs to happen over and over and over again. We don't need to keep making new boards. We don't need to keep making new scanners because they just already exist. But we do need to make new moves. So we're going to say while, and in this case, we just want this to run forever. We're going to tab all these out. If you select everything and press tab, what it'll do is all I do is putting tab. So every move, we want it to say, first of all, get an input. Second of all, parse all the inputs. Third of all, make the move. Fourth of all, print the board. Fifth of all, print out another line, and then, do it all again. So let's try this. Let's run this code. So we're going to say, 0, 0, and red. So red placed a piece there. And now we're going to say, 0, 1, yellow. And bam, there it is. So at the 0th place, at 1, we made a yellow one. So now, that's really as far as we really need to get. because this has demonstrated all of the concepts we've wanted to learn. So what the heck is there actually to do then left over? Well, there's actually quite a lot. First of all, this is going to look like a real game board. You've got to say, like, you know, these are the columns, these are the rows. You've got to number them all. You've got to probably add some way to change turns, which will involve if statements and maybe a Boolean that keeps switching every time you go through the while loop. You'll want to be able to make gravity happen. So you'll probably go through each column, like which one is the lowest piece that exists, place this piece on top of it. Quite a lot of things to do that. You want to make sure people are actually doing, you know, legal moves. Because right now, if I give it a -1 here, let's do that. Let's say, you know, -1, 0, or 1, and 2, then it's, you know, it's just going to crash. So that's the kind of thing that you need to do, but that's the kind of thing that you can do now that you know all of this. So, back to this reference thing. I have a much more complete 400-line long piece of code that is quite literally just a really big Word document or Java file, depends on which one you want. You can run it and it explains literally everything that we've learned here, plus more. Okay, so if you want to actually like reference that, it's pretty dense, like really short, but really compact. You should be able to get all the information you want from that. I hope you've learned a lot, because now that we've actually been able to make the engine for our game, we can make the game, and maybe in a couple of weeks what I'll do is I'll make a solution video where we'll build all of that and finish the game. But this is the kind of thing where other people really should, you know, where you all are really capable now and are really, you know, empowered to make the rest of it yourself, and so that the game is yours. This really is just the engine. It's, you know, 40 lines of code long. It's not that big of a deal. The rest of it, however, is. And that's something that you all should be able to do if you just think logically. So, thanks for watching. I'm Alexander Savchenkov, signing off.